Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Deep Reinforcement Learning. DRL. AI that learns from pixels. Connecting RL with neural networks. Welcome. Today, we're diving into deep reinforcement learning. DRL. A fascinating area where AI learns almost like a human. Imagine teaching a computer to play a video game. Not by programming every rule, but by just showing it the screen and giving it points when it does well. That's DRL. It's the powerful combination of reinforcement learning, learning by trial and error, and deep learning, using neural networks for complex pattern recognition. For developers, this means creating AI that can adapt and make decisions in complex, dynamic environments. Before we add the deep, let's quickly revisit reinforcement learning. Think of it like training a pet agent. This is our AI. The learner, the dog, environment, the world the agent interacts with, the living room, state, what the agent sees, knows about the environment right now. The dog sees a ball. Action. What the agent does. The dog fetches the ball. Reward. The feedback. Positive, a treat, or negative, no treat. The agent tries actions, observes the new state, and gets a reward. It learns over time which actions in which states lead to the most positive rewards. As developers, we define these components when setting up an RL problem. Traditional RL works great for simple tasks. But what happens when the state is incredibly complex? Like millions of pixels on a video game screen? It's impossible to create rules or even just memorize every single pixel combination. This is where deep learning, specifically neural networks, comes in. Neural networks are incredibly powerful at finding hidden patterns in vast amounts of data. They allow our AI to make sense of complex observations without us having to explicitly tell it what every single pixel means. They provide the brain to process the information. How do neural networks see pixels? Imagine a computer game screen. It's just a grid of numbers, where each number represents a pixel's color and brightness. We feed these raw pixel values directly into a neural network. Often, we use a special type called a convolutional neural network. CNN. CNNs are like expert pattern detectors. They're designed to automatically find important features in images, such as edges, shapes, and objects, without us needing to program, find a box, or find a character. This allows our AI to understand what's happening on the screen. This is where the magic happens. The neural network becomes the brain of our RL agent. 1. Input. The neural network takes the current state, e.g., the raw pixels of the game screen, as its input. 2. Output. Based on what it sees, the network outputs a decision. Specifically, it tells the agent which action it thinks is best to take, e.g., jump, move right. 3. Learning. The agent takes the suggested action, observes the new state, and receives a reward or penalty. This reward is used to train the neural network. If an action led to a good reward, the network subtly adjusts its internal connections so it's more likely to suggest that action in similar situations next time. This continuous feedback loop allows the AI to learn optimal strategies purely through trial and error. DRL isn't just for theoretical studies. It's powering real-world breakthroughs. Mastering games. Google DeepMind's AI learned to play complex Atari games better than humans, just by looking at the pixels and getting a score. Robotics. Robots are learning to walk, grasp delicate objects, or navigate tricky terrains through DRL. Self-driving cars. DRL helps train autonomous vehicles to make complex decisions in unpredictable traffic scenarios. Resource management. optimizing data center cooling or city traffic flow. As developers, understanding DRL opens doors to creating highly adaptive and intelligent systems across various industries. So, how would you, as a developer, dive into DRL? 1. Language and tools. Python is the standard. You'll work with powerful libraries like TensorFlow or PyTorch for building and training neural networks. 2. Environments. Libraries like OpenAI Gym provide standardized virtual environments, like classic Atari games or simple physics simulations, where you can train and test your DRL agents. 3. The process. You'll define your environment's observations, actions, and rewards. Then, you'll design your neural network architecture. Finally, you'll set up a training loop where your AI repeatedly interacts with the environment, takes actions based on its NN, receives rewards, and updates its NN to improve. It's an iterative process of experimentation and refinement. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.